A'udhu billahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. I welcome you all in our today's online session. Hope you all are fine and having good health. We start today's session of power electronics regarding chapter number 10. And we start today's session with the words of Holy Quran. So today's the topic of our power electronics course is inverters on chapter number 10. These are the list of contents that we're going to discuss in this chapter. Inverter is a type of technique which can convert the DC current into an AC. So this is the main aspect that why we need to discuss inverter, importance of inverter in power electronics applications. So without inverter, the DC current cannot be converted to an AC, and appliances which going to be operate by AC, if we have the DC current of batteries, then we have a mandatory converter that is be called inverter. So inverter are the static circuits that is have no moving parts. It's a static converter basically. There are some kind of dynamic converters that convert DC into AC, but mainly we have a static converter that we call inverter, which is convert the DC power into an AC power at the desired output voltage or current and frequency as well. जैसे कि हम सब जानते हैं कि अगर एक बैटरी अवेलेबल हो हमारे पास और हम अपनी एसी अप्लायंसेस उससे ऑपरेशन करना चाहते हैं, चलाना चाहते हैं, तो उसके लिए हमें लाजमी इन्वर्टर रिक्वायर्ड होंगे। बगैर इन्वर्टर के हम इन्हें कन्वर्ट नहीं कर सकते, चला नहीं सकते इन अप्लायंसेस को। खास तौर पे जिन इलाकों में लोड शेडिंग होती है, लाइट अवेलेबल नहीं होती, लोग बैटरी अपनी चार्ज करके रखते हैं और इन्वर्टर के जरिए से वो अपने एसी अप्लायंसेस को, अगर एसी अप्लायंस वो चलाना चाहते हैं, तो लाजमी उन्हें एक यूपीएस जिसमें इन्वर्टर लगा हुआ होता है उसके जरिए से वो चलाते हैं। अब एसी सिग्नल के लिए लाजमी याद रखें कि हमें एक खास फ्रिक्वेंसी ओरिएंटेड डिवाइस चाहिए जो कि साइन वेव प्रोड्यूस कर सकती हो, एक परफेक्ट साइन वेव, ताकि हमारी जो एसी अप्लायंसेस है वो प्रॉपरली उससे ऑपरेशन हो सके। The output voltage of an inverter has a periodic waveform that is not sinusoidal but can made to closely approximate this desired waveform. अच्छा, ये प्योर साइन वेव जनरेट नहीं कर पाते इन्वर्टर्स, जो कि अब रिलेटेड टू दी अप्रोक्सीमेट रिजेम्बलेंस टू द साइन वेव होते हैं, जिन्हें क्वाजी साइनोसॉइडल वेव कहा जाता है। There are many types of inverters. They are classified according to the number of phases. Inverters 3 phase के भी होते हैं, single phase के भी होते हैं, multi phase inverters भी होते हैं as per the need of user. Use of power semiconductor devices जिसके अंदर inverters, IGBTs, MOSFETs वगैरह लगाए भी जाते हैं. Communication principles and output waveforms. We will first look at a single phase inverter. Secondly, we will discuss voltage source inverter, VSI, that is also called, and another category of inverter is current source inverter, VSI and CSI. And finally, we will cover the principle of 3-phase inverters as well in upcoming lecture. Inverters are used in many industrial applications. इंडस्ट्री में बहुत इसका इस्तेमाल होता है इन्वर्टर्स का, खास तौर पे जो हमारी रेजिडेंशियल इंडस्ट्री है, इनके अंदर यूपीएस का, और खास तौर पे हमारी जो कारखानों की इंडस्ट्रीज है, शॉप्स की हैं, जिनमें बहुत ज़्यादा यूपीएस इस्तेमाल किए जाते हैं, वहाँ पर बेपनाह इन्वर्टर्स का इस्तेमाल किया जाता है, इंक्लूडिंग स्पीड कंट्रोल ऑफ इंडक्शन एंड सिंक्रोनस मोटर एज वेल, इंडक्शन हीटिंग, craft power supplies, uninterruptible power supplies, that is we called UPS, and high voltage DC transmission as well. Without the heavy voltage of high voltage inverters, the DC transmission line cannot be converted into an AC transmission network. First, we coming towards the basic type of inverter circuitry. Single phase inverter voltage DC supply power in this figure. The circuit is also known as the edge bridge type of inverter, in which a two switch of circuitry can be connected over there. That is switch are we called S1 and S2, and load is automatically can be operated by this scenario that switch one can be on, another was is one side can be connected to the positive one and another side could be connected from the negative one, and the switching for the positive and negative can be selective to the switching technique of S1 S2 respectively. Further, and this is a simple kind of basic inverter which can invert the technique through the edge bridge technique. एंड इसी में ये चीज उन्होंने बताई है कि S1 और S2 की जो पोलैरिटी है स्विच के मुताबिक वो पॉजिटिव नेगेटिव हम इस तरह से करते हुए चेंज करेंगे, जिनमें पोटेंशियल ऑफ वोल्टेज E1 माइनस E and E plus and minus and 0 0 can be produced over there. And automatically at this aspect the switch one can on, other remains can off, other one can on, another one can be on by automatically. Square wave can be operate like switch quasi sinusoidal wave can be operated by this way. Further, coming toward the first category of inverter, that is we call the voltage source inverter, commonly type of the inverter, and this type of voltage source inverter is the input have the DC voltage source and essentially constant and independent load current draws. The input of DC voltage may be from the independent source, such as a battery, or maybe the output of a control rectifier as well. The large capacitor is placed across the DC input line of the inverter. The capacitor ensures the switching events within the inverter do not significantly change the DC input voltage. The capacitor charges and discharges as necessary to provide a stable output. The inverter converts the input DC voltage into a square wave AC output source. So the edge bridge application in voltage source inverter is can be operate that battery of E connected over there and the load is fixed over there. The switch of S1 S2 connected, and we can operate these switches by the microcontroller or selective bit switch and automatically add load, and the square wave of AC can be occur in this way. So this is the basic voltage source inverter can be formed over there. The waveform of voltage can be look like in this form, and the current waveform of continuation can be formed by this way toward this one, toward this one. The continuous commutation mode can be fulfilled by this way. And essentially that the at the instant जब हमारा switch 1 on होता है तो switch 2 off होता है, और जब switch 2 on होता है तो switch 1 हमारा off होता है. Further, the aspect coming towards after the single aspect of full bridge voltage source inverter with a resistive load connected over there, that like this one, the switches in quantity of 4 are connected S1, S2, S3 and S4 with the diode can also be out there to fulfill the desired need of inverter. So this is the circuitry of full bridge voltage source inverter with a resistive load over there, and the waveform in this square wave can be formed like this one. The switching sequence for a square output can be formed like switch 1, 2, 3 and 4 can be on at the instants. At one instant of single phase entity we can get by this way. At same instant two switches are on and gradually two are off. So at the first stage S1, S4 are on and S2 and S3 are off. And at the end of output, the potential of plus E are formed. Respectively for positive voltage, for negative voltage, again for positive voltage and a negative voltage can be formed by this inverter technique of a square wave of voltage source inverter as well. Switching sequence can also be gradually increased from this way if switching technique can be increased. Yeah. Further, on the next stage, a voltage source inverter, the RL load can be connected over there, and the impact of R of L can be emphasized on the current waveform instead of voltage. The voltage, there is no change in the voltage waveform by the connection of inductive load. Furthermore, we further moving towards the concept of after voltage source inverter, the voltage source inverter techniques are going to discuss over there, that how much be important is. The next concept are related to the voltage source inverter is pulse width modulation based technique, which is single phase modulated technique, and multi-phase width modulation and sinusoidal pulse width modulation are the other category of pulse width modulation which is used in the inverter switching applications as well. So pulse width modulation technique are commonly used in inverter techniques of single phase full bridge inverter as well. The converter, we can see this one of switches that can be operated with the positive potential voltages, and load can be operated by this way. After the single phase, the basic entity of single phase inverter can be look like this one.